Thank you for joining this lesson. We're going to discuss Mathematics Paper 1, Section 1. This will just be a continuation of something that we started. So we'll be beginning from number 6. As we continue handling this paper, it's good I remind people of our success. Greetings to the candidates of 2024. Feel appreciated, all the best as you sit your exams. I also want to remind the other continuing students, Form 3s, Form 2s, and Form 1s of 2024 that you can get prepared for your next forms work, whereby in this program, we're going to revise work for the current class, and we also introduce students to work for the next class. Form 2s will be revising Form 1 work, Form 2 work, and they'll get an introduction to Form 3 work. Form 1s will get an introduction to Form 2 work. That is together with revision of Form 1. Then Form 3 students will get an introduction to Book 4 together with revision for the lower forms. So feel encouraged to join our lessons. Register through the number on the grid, that is 0704 15 3366. I also have to remind you of the most convenient way of purchasing airtime from your M-Pesa to any network, be it Airtel, be it Telcom, be it Safaricom. Just go to your M-Pesa menu, Lipa na M-Pesa. The pay bill number is 737356. Then the account number is the number that you intend to purchase airtime for. Then you just complete your transaction and airtime will be reflected instantly. Let's get to our paper now. Given that the logarithm of 3 to base 2 is equivalent to 1.585, evaluate the logarithm to base 2 of 36, the square root of 108, divided by 27 without using mathematical tables or calculators. So let's see how this question can first of all be simplified even before we evaluate. The logarithm to base 2 of 36, this one has been multiplied by the square root of 108. So let me first of all express all the composite numbers in terms of their prime factors. So I'll be talking about the logarithm to base 2. Now, instead of 36, I will talk of 2 squared and 3 also squared. That is an expression of 36 using the prime factors. Then now there will be the square root of 108. 108 can be written as 2 squared multiplied by 3 power 3. Then square root means raised to power half generally. Then we divide by, instead of 27, this can be expressed as 3 power 3. And now we continue. Remember, we need now to write again the logarithm to base 2 of 2 power 2, 3 squared. Then now we work out whatever is in the brackets. To work out this, we need to know that there is the product law of indices, which says when numbers have been written to some power, then there is another overall power to which they have been raised. Then we can just multiply the existing power with the power outside the bracket. 2 multiplies by a half, and that becomes 2 power 1. Actually, this can be another way of saying whenever we are obtaining square root, we just divide the power by 2. Again, this is a 3 power 3. So when we multiply by half, it becomes 3/2. Yeah. Then divided by 3/3. At this point now, we can apply again more laws of indices, whereby the logarithm to base 2 of 2/2, then there is another 2 which is power 1. Remember, 2/2 and 2/1 are having the same base and they have been multiplied. So we just add the powers, and this will take us to 2/3, then multiplied by, there is a 3/2 and 3/3/2 multiplied, which means we need to add the powers at that point. So it has to become 3/3.5. But now there is division with 3/3, which means at the end of the day, that we will have 3 raised to power 2 plus 1.5, but minus 3. And that will take us to 3/half. Yeah, 3/half. At this point now, we can apply logarithms, whereby when we introduce the laws of logarithms, there is this law which will lead us to splitting these two. The log to base 2 of 2/3, then plus the logarithm again to base 2 of 3/half. Remember, this one has been resolved due to the law of logarithms, which says in case we have the log of A plus the logarithm of B, this one is equivalent to logarithm as long as they are to the same base of the product of the two numbers. And with this law ends what we have just written. Then after this point, now we can apply another law of logarithms. Let's say the third law of logarithms, which says when we have n log A, this is the same as the logarithm of A power n. The logarithm of A power n. So applying that in the two terms, then we need to have 3, the logarithm to base 2 of 2, then plus half the logarithm to base 2 of 3. Now at this point, we can apply two laws. Okay, the law that I intend to apply is the one that says when we have the logarithm of a number to the same base, we get 1. And at that point now, I'll apply it in the first term, making 3 to be multiplied by the value of 1, since this is the logarithm of 2 to base 2. Then plus half multiplied by the logarithm of 3 to base 2 has been provided in the question at this point. So we will write it as 1.585, and this is 3 plus. When we multiply by half, this becomes a 0.7925, which means the final answer will be 3.7925. So that is the final answer when we simplify the whole question. There is a number 7. The figure below shows a circle of center O. The line PQ is 21 centimeters. The line PQ, 21 centimeters, is the tangent to the circle, such that OP is equivalent to OQ. The length OP is equivalent to OQ, and the obtuse angle POQ is equivalent to 140. So this angle is 140. Then these lengths are equal. Then PQ is 21 centimeters. Yeah, that's what we have as the instructions. Calculate the area of the shaded region to 2 decimal places. Take pi to be equal to 22/7. what we need to understand at this point is that we can express the radius because the angle at the center is already provided. Yeah, it is already provided. So now we need to work with the radius of the circle, which is equal to the length from the center up to this point. And it will be interesting to also realize that the height of the triangle POQ is also the value of the radius for this particular circle, because PQ is a tangent. So I will now be talking about that particular height, which I'm calling X. For us to get X, we need to express it now. Remember, the value of the angles now, this is equivalent to 70. And this being right angled, the angle at Q will also become 20. And now we have the freedom of using any of these angles. The angle at Q is 20. The angle at O is 70 after subdividing. So we're supposed to express the tangent. Let me use the tangent. The tangent of 20 is equal to, remember, tangent of an angle is usually given by opposite divided by adjacent length. Opposite is X out of the adjacent length, which is after division 10.5. Yeah, and this can lead us to concluding that the value of X equals to 10.5 tan 20. 10.5 tan 20. With that value of X, which is our vertical height, and at the same time it is our radius for the circle, then we need to know that our shaded area, because it is what we want to calculate now, will be given by area of the triangle minus area of the sector inside it. And through that, we will have gotten the shaded area. I know people are used to area of a segment, whereby if it's a minor segment, we would have subtracted triangle from a sector. But according to the drawings that we have on board, then for this particular case, it's a very special diagram, very unique setting, whereby it is now triangle minus sector. Triangle minus sector. Therefore, the shaded area will be equal to area of triangle minus area of the sector. Minus area of the sector. And so we need now to say that area of triangle will be given by half times base times the perpendicular height, whose value is 10.5 tan 20. Then we subtract sector. You know, area of a sector is usually given by beta over 360. Beta is the angle at the center over 360 pi r. Remember, r is 10.5 tan 20. When we say squared, we mean raising it to power 2. Yeah. So for the triangle part, when we multiply, we're going to get 40.13. 40.13, then minus 17.85. 17.85, and this is finally equivalent to 22.28. 22.28 square centimeters. So that will be the area of the shaded part, area of the shaded region, area of the shaded region.
Line in.
Number 8. Number 8 is a question on it's a question on angle properties of circles. As we continue covering all this work, I think it's good I remind people of our programs. You can purchase airtime for any network from your M-Pesa. Use the paybill number 737356, and the account number is the number that you'd like to purchase airtime for. Then enter the amount and complete your transaction. I also remind people of our programs, which are going to begin in a week's time. The program will be running for exactly 1 month. As students continue resting from the busy term 3, I encourage them to start registering so that by 11th, that will be on a Monday, we just roll out the program, and this will run for exactly 1 month up to the 11th of December. So please register and be one of us. Success greetings to all the 2024 candidates. All the best as you prepare to sit for the examinations. From the comments, I see somebody saying that it is turn 70 and not turn 20. Please understand the angle that I applied. I said at this point, now that after subdivision, we are having 70 at this point. This is 70. The angle at this point is equivalent to 20, because inside a triangle, the angle must add up to 180. Now that we already have 90 and 70, then automatically the angle at that point will be equivalent to 20. So I used the 20, not the 70. You can also use the 70 and you get your answer. You get the same answers. So apply the angle that you are interested with. You will automatically get the correct answers. Let's check our number 8 now. The figure below shows a circle center O. Then we are told that the angle BAE is equivalent to 59. Just as you can see, angle BAE is 59. The lengths of the chords CD and AB are equal. CD and AB are equal. Those are equal chords. A very serious statement. Very serious statement. Calculate the size of the reflex angle COD. The reflex angle COD. COD. The angle at this particular point. That is what we are interested in. Let's see some of the properties that we are supposed to apply in Form 2 when you are reading or learning the angle properties in a circle. One of the properties that you mentioned was that angles subtended by the same chord are equal. And apart from that, we're also supposed to know that equal chords subtend equal angles at the circumference of a circle. Equal chords subtend equal angles. And if equal chords subtend equal chords subtend equal angles, then we can conclude a few things, that this being a 59, and again, AE passing through the center becomes a diameter, and so at B, we have a right angle. That being a right angle, then the angle at this particular point can be determined, and it will be 31, following the triangle BAE. Following the triangle BAE, the angle at E becomes exactly 31. So that when added to 59 and 90, we get to 180. Now, the other angle we should tell ourselves is that if the chord AB is equal to CD, then they subtend equal angles at the circumference of the circle. And so if CD was also to subtend an angle at the circumference of the circle, then that particular angle would also have been that one. The particular angle would have been that one. the particular angle would have been that one, because it is an equal chord to AB and AB is subtending that one. Then we are saying that equal chords subtend equal angles to the circumference of the circle. So the angle theta can be determined using the property that the angle subtended at the center of a circle by a given chord equals to twice the angle subtended at the circumference of the circle by the same chord. So if CD is producing 31, then at the center it would produce 62 degrees. Now that it produces 62, then we will talk about now the reflex angle. We didn't want that angle. What we are calculating is the reflex now. The reflex. Very careful. The reflex angle, COD, which now will be applying the properties of angles at a point. Then we need 360 and we subtract 62, and this will give us 298 degrees. 298 degrees. 298 degrees. So that is the particular angle that we wanted. That is its size. So a student must be very careful when evaluating such a question. There's a number 9 here. The number 9 is on rates of work and proportions. Jen marks 3 books in 5 minutes, while Kelly marks 7 books in 9 minutes. Determine the time in hours they will take to mark 310 books working together. Working together. Very serious. Working together. Let's just simplify the question. We take it slow until it is fully simplified. We just take it slow. Jane marks 3 books in 5 minutes. For Jane, let's deal with Jane's case. For Jane, 3 books take 5 minutes. That means if we will talk of per minute, in 1 minute, then Jane will mark 3/5 of a book. 3/5 of a book. That is the rate of the work of Jane. The amount of work she can accomplish in per unit time. Per unit time. Therefore, the books that she can mark are 3/5 books. Then we can talk about who? Kelly. Let's look at Kelly's case. For Kelly, Kelly marks 7 books in 9 minutes. 7 books in 9 minutes. That means if we take our rate of work now, what about in a minute? Per minute, Kelly is going to mark 7 out of 9 of a book. So that by the time she's working for 9 complete minutes, then 7 books will have been marked. Jane marking 3 books 5 minutes means that by 1 minute she covers 3/5. So that 3/5, when you multiply that rate by 5 minutes, by the time 5 minutes are over, she will have marked the 3 books according to our rate. Now, something we are supposed to know is that when they start working together in a minute, there is what will be marked. So together in 1 minute, both in 1 minute, both of them in 1 minute, sorry. Both of them in 1 minute, then it will be 3/5 for Jane and 7 out of 9 for Kelly, and that means they will mark a 1 and 17/45 books. Both of them working together. This is now to mean that we can evaluate now the question which has been asked. Determine the time in hours they will take to mark 310 books. So hours is to say that 1 and 17 out of 45 books are being marked in 1 minute. That is true. What about 310 books? 310 books. What will be the time required for this? So it will be 1 times 310 divided by this, which means multiplying by its reciprocal. Remember, this is 62 over 45. So when we multiply by reciprocal, we'll be multiplying by 45 over 62. And through this, we're going to get exactly 225 minutes. 225 minutes. Now, going back to the question, the instructions are determine the time in hours. Determine the time in hours. So in hours, we shall divide it by 60. So that we may know the complete hours here. And this will give us 3 and 3 over 4 hours. So 3 hours, 3 and 3/4 of hours. That is the total time they will take working together to complete the piece of work. Yeah. We continue working out these questions. Number 10. Number 10 is in linear inequalities. We have to work it out. Solve the inequality 3 minus 2x. This is less than x, less than 2x plus 5 divided by 3. So for us to solve this one now, we have to extract the two simultaneous inequalities from this. The two simultaneous inequalities. The first one will run all the way up to the term just before the second inequality. So from the first term to that point, that one we call the first inequality. So it will be 3 minus 2x less than x. That becomes our first inequality. The second inequality will be just after the first sample. So all the way from where x is to this point. From where x is all the way to that point. And this means we need to begin with x less than 2x plus 5 out of 3, the second inequality. So the first thing is splitting the compound inequality into two simple statements. At that point now, you are almost done. So from the inequality 1, we can have 3 remaining here. The less than 2x becomes positive on the other side. So this will be 3x. And this means x and 1 when you divide it through by 3. So this one is the first simplified. So the first one has been simplified. First one simplified. The second one can also be simplified, but first of all, we cross multiply by 3 so that we have 3x, 2x plus 5. At this point now, we need to have x, because when 2x is brought to the left-hand side, it becomes negative. Then this is less than 5. This one has also been fully simplified. Now, when they are both fully simplified, remember the instructions are and show the solutions on the number line. So now we have to represent this solution on number line, whereby we are going to have limits of x all the way from 1 to 5. From 1 to 5. If this is 0, if this is 0, then we will talk of the negative numbers, -1, -2, increasing towards the left or decreasing anyway. Then we have 1, 2, 3, 4, 5, 6, and they will increase towards the right. This is the number line where we are going to represent our inequalities. So our inequalities are beginning from +1 all the way to +5. All the way to +5. So that is the range, and we can illustrate it on the number line. From 1 all the way to +5. It's good for students to know that we are having strictly less than. There is nothing like or equal to. So when the simple inequality is not having or equal to, then it means the limits that we are having are not included. If they were included, then we would have shaded where they are to show that they are part of the integral values. But in a case like this, we don't include. So we don't shade because the limits are not included. Number 11, it's a question on trigonometry. Given that the tangent of x is equivalent to 2.4, evaluate without using tables and calculators the sine of x minus the cosine of x in the form of a over b, where a and b are integers. Very serious instructions. So the first thing that we're going to do is we just sketch a triangle whereby we locate an acute angle x whose tangent has been given there. So we come up with a simple triangle which is right angled. As you can see. Yeah, this is right angled triangle at this point. Then we can let this angle here be our x. That being our x, we have been instructed simply that the tan of x is equivalent to 2.4, which can be expressed as now a fraction, 24 out of 10. That being 24 over 10, we can even simplify it, which is not a must, but we can simplify it to by 2, 12, and by 2, 5. When simplified, it's just the same. 12 over 5 is 2.4. 24 over 10 is 2.4. So the simplification does not affect. But now the next question to ask ourselves is, how do we get the value of tangent of an angle? Tangent of a given acute angle is usually given by the opposite length divided by the adjacent length to that angle. If this is so, then we can say, according to the expression there, then the adjacent length is having 5 units. The adjacent length is having 5 units, sorry, and the opposite one is having 12. At that point now, we can apply Pythagoras theorem. 12 squared plus 5 squared, and we obtain the square root. That gives us 13 units, sorry. 13 units as the hypotenuse for this particular triangle. Yeah, so that is it. At that point now, we can continue now and simplify what we had been instructed to simplify. The sine of x, sine x is going to be given by Let me use the space here. Sine of x, sine is given by opposite of hypotenuse. The opposite length is 12 and the hypotenuse is 13. Then the cosine of x is adjacent out of hypotenuse. So 5 over 13. And this means what we are told to evaluate is 12 over 13 minus 5 over 13. This will give us, the LCM is 13. So this will give us 12 minus 5, giving us 7 over 13. Now both 7 and 13 are integers. Both 7 out of 13 are integers. Good morning to everyone. Thank you for passing the greetings. Remember to subscribe. Remember to share this link with your friends so that they may also continue learning with us. Please share the link with a friend. Remember to subscribe. Remember to like, and all shall be well. We are continuing. There is a very interesting question in number 12. Very interesting. The figure below shows the graph of a curve whose function is y equals to ax squared plus bx plus c, where a, b, and c are integers. A, b, and c are integers, not constants. They are integers. So the graph is already displayed here. Determine the equation of the curve. Determine the equation of the curve. This is a simple question, but it has been asked in a manner that if a student is not very serious, they may not know what is happening. So the graph has been drawn very carefully such that we can see the y-intercept, the x-intercept of the curve, and through this, we can be able to evaluate this equation. Remember, at this point on the x-axis, the value of y is 0. But now we are seeing the points of x at the time where the curves are intersecting, where the curve is intersecting that line is -2 and 5. And this means that if we were to solve a certain quadratic equation using the line y equals to 0, then the values of x would have been -2 and x +5. So these are the roots of a certain quadratic equation, whereby now we have to say that if the value of x is this and the value of x is also that, then we can simply solve and evaluate the quadratic curve itself using the factorization method, whereby, because the factors are provided, not even the factors, but the roots of the equation are provided, we need to tell ourselves that if x equals to -2, this is a clear indication that x plus 2 then equals to 0, and also x minus 5 is equivalent to 0. That one goes without saying. So after that rearrangement, we again ask ourselves, in case we were solving a quadratic equation, before this step, what was the previous step? And that would have been x plus 2 together with x minus 5. This is equal to 0. That is equal to 0. Then now, before the factorization, which gave us this, we had an expanded function. So we have to expand the left-hand side, whereby x multiplies everything in the other brackets, and also 2 multiplies everything in the other bracket. So with this, we will talk about x squared minus 5x plus 2x minus 10 equivalent to 0. Yeah. Then we rearrange x squared minus 3x minus 10 is equal to 0. And if this is so, then it means the function which has been plotted there as the equation y equals to x squared minus 3x minus 10. So this is the equation of the curve. This is the equation of the curve. We just use the x-intercept to know the roots of x, so that now we first of all get the quadratic equation which was solved. Then now we'll be able to conclude the equation of the function being plotted. I want to encourage the students in lower forms to register to this powerful program, whereby we're going to have one-on-one classes. Google Classes will enable students to ask questions from their point, just from your home, from wherever you'll be following from. It will be an interactive process. You ask questions, I respond. I give you questions, you respond, and the learning continues. Register on time. Register on time. Use the number which is on the grid here, 0704153366. Please use this number for any consultations and also for your registration. It's also our M-Pesa number. Solve for A and B in the following simultaneous equations using matrix method, giving their exact values. Giving their exact values. So the first thing that I'm going to work out here is a rearrangement of what we are having. A rearrangement means that this being the first equation, it can be rearranged in a better way, such that we begin with half a plus b equals to 2. And at this point, I can also continue rearranging, whereby to do away with fractions so that I may work with decent figures, I can have a plus 2b. This is equivalent to the value of 4 after cross multiplying or multiplying through by 2. On the other side, we're also having half a, and we can multiply through by, this is half a. It's another way of writing half. So with half a there, we can also multiply by half throughout, by 2 that is, and this equation can simplify to a minus 64b. This is equal to negative 10, negative 20, sorry, negative 20. So this is the first equation. This is the second equation. These are linear equations, but now we can write what we call matrix equations. Matrix equations from this. To write matrix equation, we need to have one. You remember I'm extracting the coefficients matrix first. 1, then the other one is 2. Then here I also begin with 1 and negative 64. Negative 64. It's negative. This is called the coefficients matrix. Then there is what we call variables. Variables matrix. So the variables are A and B. They also have their own matrix. And finally, we have the constants matrix equals to 4 and negative 20. This is called the constants matrix. Constants matrix, variables matrix, and the coefficients matrix. Now, with the matrix equation, let me handle this one by first of all determining the inverse of the coefficients matrix. inverse of the coefficients matrix. So we will start with getting the determinant of the coefficients matrix. That's going to be negative 64 by 1 minus 2 by 1. We usually take product of elements in the leading diagonal minus product of elements in the other diagonal. Negative 64 minus 2. That will give us negative 66. Negative 66. So the inverse of the matrix will be when we divide all the elements by the determinant, but we have a rearrangement of the elements. Negative 64 taking this position and 1 taking this position. So we are exchanging the position of the elements in the leading diagonal, but for the other diagonal we change the sign. If this is a 2, becomes negative 2, 1 becomes negative 1. So this is the inverse of the coefficients matrix. The other thing now is to pre-multiply. So that we begin with negative 1 out of 66 into negative 64, negative 2, negative 1, 1. Then we are having now 1, 2, 1, negative 64. Then there is A, B. This is equivalent to negative 1 over 66 into negative 64, negative 2, negative 1, and 1. Yeah. Then now this will be multiplied by 4, negative 20. Now on the left hand side, it's a matter of applying knowledge. Knowledge means that we know that a matrix times its own inverse should give us the identity matrix. And the identity matrix is given as 1, 0, 0, 1. This is called the identity matrix. When we multiply this matrix and this one, the answer is fixed. And that applies for any other matrix together with its own inverse. Any other matrix together with its own inverse. Any other matrix together with its own inverse, they will give us the identity matrix. Then multiplied by the variables matrix. Now on the right hand side, now we have to carry out multiplication. The multiplication of matrices whereby we multiply row times column. This row times the column. So we need negative 64 by 4 by 4. Then we add negative 2 by negative 20. This is giving me negative 216. Negative 216. Then we go to the other row and the column. The other row and the column. So how do we carry out that multiplication? Negative 1 by 4, then plus 1 by 20, and this will give us positive 16. Yeah, that will give us positive 16. Remember, I've taken negative 4, negative 1 by 4, then plus 1 by negative 20. 1 by negative 20. No, I must confirm that. Negative 1 by 4 and 1 by negative 20. This is giving us negative 24. Yeah, negative 24. That way. So with this now, on the right hand side, we will be able to divide by 66, but on the left hand side, we know that the identity matrix multiplied by any matrix, the matrix remains unaffected. So AB remains unaffected, and this is equivalent to when we take negative 216 and we divide by 66, which is having a negative, we'll get positive now. Yeah, we get a positive 3 and 3 over 11, 3 and 3 over 11. Then on the other side, when we take negative 1 over 66 by negative 24, we also get a positive number because the negatives will cancel, 4 over 11. Which means now we can take the value of A as 3 and 3 over 11, and the value of B is 4 out of 11. So at that point now, we can see that we have obeyed our instructions, which are very simple, giving their exact values. Exact values means that if it's a fraction, don't make it a decimal, whereby you will end up rounding off. When you round off or when you truncate, then you will not have given exact values. There will be error due to truncation, there will be error due to a rounding off. But with fractions, the values are exact. There is a number 14, sorry. Number 14 here. Number 14 is on solve for K, the equation. So this is a question on indices. Remember that the line through which you should consult is 07, 04, 15, 33, 66. Please consult through this line. It is through the same line that students are going to register for these programs. Feel free to register, feel free to call, feel free to use SMS, feel free to WhatsApp. Register for this powerful program. Learners are really going to reap a lot. Remember also to purchase airtime for any network from your M-Pesa. Use the pay bill number 737356. Then the account number is the number that you'd like to purchase airtime for. Then you proceed by entering the amount and you complete the transaction. The airtime is going to reflect instantly. The airtime shall reflect instantly. Number 14. Solve for K. Solve for K in the equation. 2 out of 5 raised to power 2 multiplied by, sorry for this, yeah, multiplied by 2 over 5 raised to K. This is equivalent to, let me simplify 125 out of 8, whereby I'm going to take the cube root of each. Taking the cube root of each means that I'll remain with 5 out of 2, and power 3 comes out. Power 3 comes out there. Then out there it defines K minus 1. Yeah, it defines K minus 1. Want to continue solving this, whereby I can rewrite 2 over 5 power K multiplied by 2 out of 5. The first one is power 2. The second one is the 1 power K. This is equivalent to, there is the negative law of indices, which says that, or before the negative law of indices, let me take it slow. Let me apply the product law of indices first, which says that 3 has to multiply everything there. 3k minus 3. Yeah, at that point. At that point, exactly. So 2 out of 5 power 2. 2 out of 5 power k. This is equivalent to, we can now apply the negative law of indices, which says in case we obtain the fraction, the power reverses its sign. So we take reciprocal of 5 over 2, making it 2 over 5. Then the power reverses its sign. 3k minus 3 becomes now negative 3k plus 3. Negative 3k plus 3. That way, we reverse the power once we have taken the reciprocal. We reverse the signs of the power. At this point now, we can apply the, there is the multiplication law of indices. The first one, the multiplication law, whereby if the base is the same, then we have to take 2 out of 5 raised to 2 plus k. We just add the powers. This is equivalent to 2 out of 5 negative 3k plus 3. So at this point now that we have all the bases the same, we can simply equate the powers now. 2 plus k equivalent to negative 3 plus 3. And at this point, we can now group like terms together so that we have 4k equals to 1. And at this point, we can get the value of k as a quarter. That is when we divide through by 4. So that is simply how we work out such a question. Very interesting. Very interesting question. There is a number 15. Remember, we are winding up. Thank you so much for being around. Thank you for following. Remember to subscribe. Please subscribe. Remember also to share with a friend. Remember to share with a friend. Yeah, number 15. Under a translation T, point A, negative 3,5 is mapped onto A prime, negative 2,7. Find the coordinates of point B, given that B prime is 0, 1, is its image under the same translation T. We should know that a translation vector, when we add the coordinates of the object, we should get the coordinates of the image written in column vectors. So they are known translation T. When we add A, we're supposed to get the image. And through this, we can get the translation vector, whereby X will become, this is a negative 3. Taken to the other side, it will become positive. So negative 2 plus 3 gives us 1. Yeah, negative 2 plus 3 gives us 1. Then for us to get Y, we need to say that this is a 5. Taken to the other side, it will be negative. So 7 minus 5 gives us 2. So the translation vector is 1, 2. The translation vector is 1, 2. Now, being 1, 2, then it means we can now go to the case of B, whereby we say the same translation vector plus the unknown coordinates of B we should get the image of B, which is 0, 1. So the coordinates of B can now be worked out. At this point, we will be talking about A, -1, because to remain with A there, we have to take 1 to the other side. Then to remain with B, we have to take 2 to the other side. So it will be 1 minus 2, giving us a -1. At this point now, we'll say that the coordinates of B are -1, -1, -1, -1. So this will be the coordinates of B. Just look at the question keenly. You discover it is so. Yeah, that is it. Number 16. Number 16. Remember to subscribe as you get reminded of our program here. Register your siblings, register your brother, register your sister, register your son and daughter. Just bring people on board for them to grow with shifting grades. The number that you register with is 0704 1533. It's 3366 3366 33. So please follow up with that number and see how to register. The distance from a fixed point of a particle in motion at any time t seconds is given by s equals to t power 3 minus 5 over 2 t power 2 plus 2t plus 5 meters. Find the velocity when the acceleration is 0. Find the velocity when the acceleration is 0. Okay. This being a distance function, we should go to the velocity function. For us to get velocity function, we say that we need to differentiate distance with respect to time. So this shall be, we drop the power here, so 3t, the power now becomes power 2, then minus 5 over 2 t squared. 5 over 2 t squared. That means we drop the power here, so that it becomes 5 over 2 times 2. That gives it 5. Then t, which was squared, now becomes t power 1 plus 2t. T is to power 1 at that point. So we drop 1, so it will be 1 times 2. And t, which was to power 1, now becomes power 0. When t becomes power 0, its value is 1. So it disappears. And the constant, which was 5, also disappears after differentiation. So this is our velocity function. For us to get acceleration function, we have to differentiate now velocity with respect to time. To differentiate velocity means that the power here of 2 goes down there, so that we have 3 times 2, giving us 16, then minus 5, t is to power 1, so 5 times 1 is just 5, and t, which was to power 1, now becomes t power 0, making its value 1. The constant disappears. So this is our acceleration function. Now find its velocity when acceleration is 0. When acceleration is 0 means that we can get the value of t. When acceleration equals to 0, what will be the value of t? The value of t will be 5 out of 6. 5 out of 6. But now we need velocity at this particular time when acceleration time, at this particular time when acceleration value is 0. T equals to 5 over 6. So the value of velocity at that particular time will be 3. T squared means 5 over 6 squared minus 5, then 5 over 6 plus 2. And this can be computed now. This can be computed. 3 into 5 out of 6 squared minus 5 into 5 over 6, then plus 2. This gives us exactly negative 1 over 12. Being velocity, meters per second. Being velocity, then meters per second. So the section 2 is going to be discussed on a later day, but it's a very good paper. Please plan to be with us in our next live broadcast. Thank you so much for following. Remember to subscribe and share. Remember to subscribe and share. Remember also to register for our programs here. Remember again to purchase airtime using our account, whereby you go to M-Pesa. When you go to the M-Pesa now, pay bill number is 737356. Then now the account number is your phone number. The phone number that you'd like to purchase airtime for could be Safaricom, Airtel, Telcom. Just enter the phone number. Then after that, you proceed by entering the amount and you confirm your transaction. Airtime is going to reflect instantly. Thank you so much. See you next time.